All right, now formal lecture today is not going to be very long at all. Okay, so I'm done with everything except for 6.7, which is on parametric equations. I basically have 3 days to do it, today, Monday, and Tuesday. So today I was just going to introduce the concept and then go ahead and give you the quiz, and then that'll be it. Okay, so Monday, Tuesday, parametric equations. Wednesday, questions and answers. Thursday's the last regular test. Friday, questions and answers about the final. And then we're done a week from Monday, Monday the 14th, final exam, 8:10 to 10:40. Okay, so for Thursday's test, as usual, you submit just this. It's not that much, as you can see. By the way, quick word about the 1 to 19 odd. It looks like it's not that long, but some of the problems have parts A, B, C, D. So like from 13 on, you look at 13, 15, it's A, B, C, D, A, B, C, D. Okay, so it's not as short as you might think. Okay, it's still kind of short, but not super short. Okay. All right, and a reminder, how do I study for the final exam? Just go back over the old exams. You can use all the previous formula sheets. Okay, so you should already have, 5 formula sheets from the first 5 tests. Okay. If you lost them or threw them away or whatever, you can remake them. You can add to it. Okay, so on a particular test, you might have said, oh, I wish I would have put that formula on. You can do that. Go back and put some more in. Okay, so you're building the 6th one, and then by the time of the final exam, just have them all, and then we're done. Okay. All right, so I'm going to introduce 6.7, not go very far with it at all. Something called parametric equations. I'll just do a couple problems, and then we'll go straight to the quiz, and then have a good weekend. Okay, that'll be our last regular quiz. All right, so parametric equations, 6.7. Page 360. All right, so they're going to give us 2 functions. X is a function of t, y is a function of t. Okay. I say t, but it could be some other letter. See, x, y, x, y, x, y. Function of t. Sometimes it might be a function of theta, okay, but most of these look like it's a function of t. Okay. Notice we can make a table, t, x, and y. So based on these parametric equations, okay, so these 2 are called parametric equations. T is sometimes called the parameter. It's basically another variable. So are x and y related? Yes, they're related because they're both related to t, so to speak. All right, and they tell me that t goes from -1 to 1. They don't have to tell you this, though. If they don't tell you, then you can pick whatever you want. Okay. So notice they made a little table. T versus x, right? Plug in a t, you figure out the x. That's easy enough. So they made a little table. From here, same thing with y. So if I go like that, t versus y, you can make a table. And then when you plot the points, just plot x and y, as usual. Okay. So it ends up looking like this. Okay. Notice they actually put the t values. There's a good reason for calling it t. T quite often stands for time. So this could be thought of as a passage of time. Okay, this looks like it's part of a parabola, but the arrow indicates increasing t, increasing time. So here t is -1, -0.5, 0, 1/2, 1. So it looks like the graph is going this direction, like the motion of a particle. Particle is moving in this direction. Okay. Now, quite often, you can solve for t and then eliminate the t to just get something that we're used to, x and y. Okay, so for instance, a little bit of algebra can convince you that t is equal to x minus 1 divided by 2. Right? If you isolate the t here, subtract 1 divided by 2. So you can get t equals x minus 1 over 2. So if I were to take that expression and plug it into here, y equals this, 4t squared minus 1, do a little of algebra, and it ends up looking like that. Then you say, okay, I recognize that. That's a parabola. You won't always be able to do that, but for the problems that we have, you pretty much can do it. Okay? So you can get rid of the t, the parameter t. Okay? So we say parameter, it's just another variable. Okay? You're not always going to be able to do that, but most of the time you're going to be able to do that. Get rid of the t. So you just have some relation in x and y that we're familiar with. Okay. So all I'm going to do is show you a couple, and then that's pretty much about it. Okay, so I was going to show you 1 and 3 on page 364, and then stop there because I still have Monday and Tuesday to do the rest. Okay, x equals 3t, y equals t over 2. So notice all of these are x and y. Okay, x is some function of t, y is some function of t. Okay, I could make a table, but they actually want you to find a corresponding rectangular equation. You say, what's a rectangular equation? It's an equation that only has x and y, because it'll have your regular rectangular coordinates. Basically, it means get rid of the t. Sketch the graph of the curve described by the parametric equation. So these two are called parametric equations. T is the parameter. Okay, and showing a possible when t equals 0 and the direction of increasing values of t. Right. So which way does the graph go as t, normally standing for time, increases? All right. So number 1, x equals 3t, y equals t over 2. So let me show you that one. X equals 3t, y equals t over 2. Okay, so first thing I did was made a little table of t, x, and y. Okay. Because I noticed y is t over 2, I chose even numbers. So I went -4, -2, 0, 2, and 4, because I knew I had to divide them by 2, so I wanted nice numbers. Okay. So first, I plug into just here. So you know how we were beginning, first time you ever learned graphing, you did x and y, right? Where y is a function of x or x is a function of y or whatever. Okay. So I have t, x, and y. So I plug in t, figure out the x. Okay, so x is 3t, so no big deal. Plug in -4, -12. Plug in -2, -6. Plug in 0, 0. Plug in 2, 6. Plug in 4, 12. Okay. All right, now I plot t versus y. Y is t divided by 2. So ignore the x column. Okay. So plug in -4, y is -2. Plug in t is -2, I get y is -1. Plug in 0, you get 0. Plug in 2, you get 1. And plug in 4, you get 2. Right? So I end it with this. And then when I plot the points, I totally forget about the t and just plot the usual x versus y. Okay, so I have -12, -2. That's way over here. -6, 1, 0, 0, 6, 1, 12, 2. And as t increases, it looks like we're going in this direction. So that's why I drew an arrow. Looks like a straight line. Okay. Can I prove it's a straight line? Yes. So I made a table, but can I eliminate the t? Sure. Here, t is equal to x over 3. Right? Divide both sides by 3. And now I put x over 3 right there. This x over 3, put it right there. So it's x over 3 divided by 2. And I think I showed you this shortcut before. If you have something that looks like this, that 3 can slide down with a 2. So it becomes x over 6, or 1/6x. Okay. One way you can convince yourself that that's legal is multiply top and bottom by 3. Put 3 over 3. The 3's cancel out there, and 3 times 2 is 6. So y is equal to x over 6, or 1/6x. And yes, we do recognize that as a line. That looks like y equals mx plus b. Slope is 1/6, and b is 0, so it touches the origin. And there it is. So yes, indeed, we did prove that this is indeed a straight line, okay, with the equation y equals 1/6x. And it's going in this direction as time increases. Again, you can think of this as the passage of time. As time goes by, the particle, the object is moving in this direction. Okay, and yeah, unless we say otherwise, there's no reason to exclude negative numbers. You can plug in negative numbers, okay, for t, although, quite often in most experiments, science experiments, you might begin only with 0. So you would go something like this. Or, for problem 3, maybe there's something already in the problem which doesn't allow you to have negatives. Okay, and number 3 is such a case. Okay, so number 3, and then that's all I was going to do. I was going to stop after number 3 and then go ahead and give you the quiz. So looks like you'll have half an hour or more to do it. Okay, x equals square root of t, y equals t plus 1. Okay, here you're not allowed to plug in negative values for t, right? And for right now, we're only doing reals, so none of the imaginary stuff, the I, right? We're not going to do any of that. So you're not allowed to plug in -1 or -4 or whatever. So I'm forced to plug in only 0 and positive stuff, right? All right, so x equals square root of t, y equals t plus 1. Okay, so I make myself a little table. Okay, temporarily ignore that square and ignore that squared. Okay, so I plug in t. I'm not allowed to plug in any negatives. But I'm going to plug in numbers that are perfect squares. I have to take the square root. So I plug in 0, 1. I don't want 2. I don't want plot square root of 2. I don't want square root of 3. 4 is okay. Not 5, 6, 7, 8, but 9 is okay. And yes, I have to plug in here too, but that's no big deal. It's easy to add 1. Okay, so 0, 1, 4, 9. Okay, so x is the square root of t. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Okay. That's the reason why I intentionally picked 0, 1, 4, 9, so I would get nice numbers. Now, the y values, easy, t plus 1. So just add 1. So 0 plus 1, 1. 1 plus 1, 2. 4 plus 1, 5. 9 plus 1, 10. And now, I just plot the usual x versus y. But this can be thought of as the passage of time as time increases. Okay, so I made my little chart. Notice I just had a first quadrant view because all my points are either 0 or positive. So why devote space to quadrants 2, 3, and 4 when you know there's no graph there, right? I just made it a first quadrant graph essentially. Okay, so 0, 1, 1, 2, 1, 2, 1, 2, 3, 4, 5, and 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the arrow is going this way as time increases. So it's going like that. It's certainly not a straight line. Maybe it's a parabola. We can show it's a parabola. Okay, so back to here. Can I solve for t? Sure, square both sides. So that's why I squared. That means t is equal to x squared. T is equal to x squared, put x squared right there. So y equals x squared plus 1. There it is. So this is part of the graph y equals x squared plus 1. But you might say, what about this part over here? Okay, so if this was just a standalone problem and said x squared plus 1, right? Then you would say, okay, I know what y equals x squared looks like. It's U-shaped, touches the origin, and then plus 1 means translate 1 unit up. So it would be like so. Okay? Then how come I don't have anything over here? It's because of this restriction from the original problem. Okay, if I have anything over here, that means x is negative, right? In quadrant 2 and 3, x is negative. But you can see I'm not allowed to have any negative number, right? When I plug in anything for t, it can only be 0 or positive. Therefore, its square root's got to be positive. So even though the relation is y equals x squared plus 1, I don't have the part of the parabola that's over here, right? So that doesn't exist for this problem. I only have the right half, the right part of the problem. Okay, so sometimes you get an equation that you recognize, but because of the limitations of the original problem, you may not get the entire graph, right? So at first glance, you say, oh, y equals x squared plus 1, that's the whole parabola. Yes, but because x is equal to square root of t, that tells me, okay, I'm only allowed 0 and positive numbers for t, and the square root of any of such numbers can only be positive. So that tells me I don't have this piece of the graph. I have just this piece of the graph right over here. Okay. All right, that's what we're up against for parametric equations. All right, so I just gave you a little taste of it. So if you want to look ahead, for the weekend to see how some of these can, you may. But I still have Monday and Tuesday to go over the rest of these. So maybe Monday I'll knock off these. Might be a little bit harder to knock off these. So, but I should be able to finish everything by Tuesday, hopefully. Okay. All right. So that's it for the formal lecture, folks. So if nobody has any questions, we can go straight to the quiz. Let me check quickly the chat. Nothing in the chat. All right. So does anybody have any question, please? Wait just a moment, and if I don't hear anything or see anything in the chat, we'll go straight to the quiz, and that'll be it, and then have a good weekend. Okay, I don't see anything. All right, so get your cell phones out as usual. Then I'll set up your breakout rooms, and then it's due Monday, 9/10. Right? And we're still recording, so worst comes to worst, you can look at the recording. All right, number 1, graph the ellipse. Label the vertices and the foci. X squared over 16 plus y squared over 25 equals 1. Number 2, graph the hyperbola. Label the vertices and the foci and give the equations of the asymptotes. Y squared over 9 minus x squared over 16 equals 1. Okay, I'll hold it here for a few more seconds, then I'll make it disappear. I'll set up your breakout rooms, and that'll be it for today. Okay. All right, I will assume everybody has a picture of this. Worst comes to worst, you can look at the video later. Okay, so go ahead and get started with that. Let me set up your breakout rooms. Remember, I might move you from your breakout room if your breakout room has too few. Okay, so you should be able to join your breakout room now, please. So can everybody please go to your breakout room?